Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 48, Liquids and Solids, Part 3. Here are our objectives for today's video. Pause here. You don't need this picture or any of these pictures in this video, except for the one that I will tell you that you need. All right, so we're going to be talking about types of solids today and how we can make predictions about their behavior based off the type of solid. So the first type is an atomic solid. So this consists of atoms that are held together with London dispersion forces. So for example, that could be iodine, not in the I2 form specifically, just I, or charcoal, which is just a bunch of carbon atoms. These in general will not conduct electricity. There's exceptions to everything, but generally speaking, they will not conduct electricity. Pause here. So the second type is molecular solids. It's very, very similar to atomic, just instead of having atoms, we have molecules. So when we have something that is covalently bonded, whether it be nonpolar covalent or polar covalent, so long as it's covalent of some sort, if it forms a solid, it will be a molecular solid that is held together with London dispersion forces. So for example, dry ice, CO2, or graphite, which is carbon that forms a molecule, which is what is in this drawing that you don't need in your notes. And in general, these will not conduct electricity. There's exceptions, but generally speaking, these will not conduct electricity. Pause here. You don't need the picture. The third type of solid is a metallic solid. So these are held together by what is sometimes called the electron sea, which just means that electrons are delocalized over multiple atoms and it holds the atoms together. Sometimes you'll hear it called metallic bonding. I don't really like that term because to me, bonding is constructive overlap of atomic orbitals, and that's not what's happening here. But what's important is that it is held together by this delocalized sort of bonding of sorts. Iron or copper are examples of this, and this conducts electricity. As I'm sure you're aware, wires all conduct electricity, but it conducts electricity because we have mobile charged particles, specifically the electrons. Pause here. You do not need the picture. So when certain things form covalent bonds, they don't just stop by forming one unit and then they stop. They can keep bonding pretty much indefinitely until they run out of things to bond with. So carbon is the example you're probably most familiar with because it can form diamond. It is theoretically possible for one diamond to just be one molecule. So even though it is just London dispersion forces, we can have extremely high molar masses here. And so you'll have very, very high boiling point melting points. Generally speaking, these substances will not conduct electricity. There's exceptions to just about everything, but by and large, they will not conduct electricity. Pause here. All right, I'll go through these one by one. Right, cesium chloride, that is an ionic solid. So I'm going to look for the description of the ionic solid, which happens to be the first one, lattice of positive and negative ions held together by electrostatic forces. Gold, Au, that is a metallic solid. So that actually is the second one, closely packed lattice with delocalized electrons throughout. Carbon dioxide, that is a molecular solid. There are actually two things here that can describe molecular solids, both the third and the fourth one. But because carbon dioxide has a double bond, whereas methane has just a single bond, carbon dioxide is best described with strong multiple covalent bonds, including pi bonds with weak intermolecular forces. Don't worry about the pi bonds thing. I can explain it in class, but you don't actually really need it. Methane, that is a molecular solid, even lower intermolecular forces than CO2. So that would be the third one, strong single covalent bonds with weak intermolecular forces. This is from the 1998 AP Chemistry exam. This question. Pause here. I would do a rough sketch of the picture. Right, so for just about any substance that is a real substance that is commonly used in a lab, you could look up what's called a phase diagram, which can show you how the states of matter depend on temperature and pressure. When we have the lines, that is when the phases are in equilibrium with one another. And then when all of those points meet, so that's point D here, we have what's called a triple point where all three phases of matter are present with one another. So there's a specific set of temperatures and pressures for most substances where you will see the triple point. So not all phase diagrams are going to look exactly the same, but the vast majority of them will look similar to this, where the liquid is in the upper right-hand corner, but you typically just look them up. You're not going to need to make them. You just might need to be able to use one. Pause here. You don't need to draw the picture. All right, so I'm looking for an equilibrium between solid and liquid. So I'm going to look for anything along this line. So you could say D and you could say E, and both of the answers would be correct. Either way would work. Pretty sure that there was more information in the question that made it such that you had to pick D or E when this was on the 1998 AP exam. All right, thank you so much for watching and have a great night.